Hello and welcome back. The topic for this video is going to be the scientific method. All right. I know out there are going to be a number of you sitting watching this video thinking, you know, science is just hard. It's always been hard for me. And in terms of that, I'm not going to say yes or no, and that's true or not true in your case. But what I hope to expose you to is that really science is a way of thinking, okay? And you've actually been a scientist since you were a little kid. Because when you were a little kid, you asked a lot of questions. You asked why? Probably to the point where you annoyed your parents to death, all right? And if you have small children, you're already very aware of this phenomenon, all right? Scientists, or people who stay in science, really never grew out of that phase. They're still all about asking questions, okay? And they ask questions based on observations that they see in a lab, out in nature, all right? But really, you have been using the scientific method in your day-to-day life, all right? And I've kind of got an example of that posted in the PowerPoint slides about what happens or what you do if your car doesn't start one day, okay? Science is really about solving a problem, okay? And in terms of the scientific method is really the way that scientists go about testing a particular idea, okay? Typically what starts the process is going to be an observation of some sort, okay? And that observation leads the scientist to form a question, okay? That question typically is in the form of a hypothesis, all right? And this is going to be one of the things that I want you to be able to identify and be able to come up with as part of this class, is to come up with something that could be a testable hypothesis, okay? And that's one of the keys to a particular statement being a hypothesis, is it has to be something that you can test, okay? Now, typically with a hypothesis, it is written as an if-then statement, okay? So if I do this, and I'm going to put this in parentheses because maybe the do this, all right, is related to something like, maybe if I stop watering my plants, okay, then this would happen. So an example of a hypothesis would be, if I stop watering my basil plants, then the plant will dry up and die, okay? It's testable because you can withhold water from your plants, okay? And you will see a result from it, okay? I don't recommend not watering your basil plants because you're probably already aware if you stop watering plants, they will die. And if you want to have basil to put into your food, you know, you want to water your plants, all right? But another example of a hypothesis might be if you wanted to say, because you're here in New Mexico, have noticed that, wow, a lot more people here in New Mexico seem to have skin cancer. So maybe what I'm going to propose is if exposure to UV light causes skin cancer, then people who are exposed to high levels of UV light will have a higher rate of skin cancer. Again, it's testable. It's something you could potentially do, although in this case, this particular experiment would run into some problems because of, with clinical studies, if you're going to expose people to UV light and cause damage, typically that's not what you want to do, okay? But that would be something that could be tested. And that's something else that brings up something that has to do with forming a hypothesis, is that you also want to consider with your hypothesis, is this something reasonable to test, okay? Intentionally exposing people to high levels of UV light would not be good for their health because there have already been studies done to show that UV light is indeed linked to increased incidence of skin cancer, okay? So in terms of that, what you want your hypothesis to be is something that's testable, also something that's falsifiable, all right? You can have something as simple as, if I drop this pen, then it will fall to the ground, okay? It's testable because I can take this pen and let it go. It fell. In this case, it fell on my table. It didn't fall all the way to the ground, okay? But in terms of that, you had a result that you gathered, all right? But if you get something that's more generic, if you say, I can drop any object and it will fall, that's something that's falsifiable. Because if you get a helium balloon and let go of a helium balloon is not going to sink to the floor, it's going to go up. So that would be an example of how you would falsify a particular hypothesis, all right? And one of the things that's truly amazing about science is that making a mistake or having something not come out the way you expect it to isn't necessarily wrong, okay? What it does is that allows you, from your hypothesis, okay, to come up with an experiment to test your hypothesis. From that experiment, you are going to gather results or gather data. And from those results, you can either again, me with spelling. You can either support or not support your hypothesis, okay? But either way, those results are going to lead you to a particular conclusion, all right? Your conclusion might be that you need to revise your hypothesis and either make it more specific or possibly change it entirely, okay? That's really the steps that scientists go through in solving problems. And you do this every day when you tackle problems that you come across in life, like the example of your car not starting, okay? So in terms of the hypothesis, all right, really a hypothesis is your best guess. It's an educated guess because you're basing it on some observation, but it's your best guess to predict a solution to a particular problem, okay? So it's a way to answer your question, all right? So in terms of the hypothesis, what I want to have you be able to do, what I want to see you be able to do is write something that's an if-then statement. If I do this, and you can insert anything in there that you want to potentially look at, then predict what would happen, okay? That's part of the scientific method, all right? Forming a hypothesis is an important part of the scientific method, all right? And in terms of that, forming a hypothesis and hypothesis-driven science is kind of one arm of science. You also have what's known as descriptive science, all right? Descriptive science is more observational, and typically it's descriptive science that leads you to hypothesis-driven science, okay? So the two kind of play hand in hand, all right? You need both. There isn't one that's necessarily better than the other. All right. But in terms of that, when we're talking about science and testing our hypothesis or running the experiment, all right, the other thing I want you to know with the experiment, you put this over here, is you are going to have two variables. Okay? You're going to have the independent variable, all right? And this is going to be the variable that you control. So in terms of going back to me watering my basil plant, adding the water would be the independent variable, okay? Then you are going to have a dependent variable, okay? This is going to be what you observe, okay? So in this case, if I don't water my plants, if I take away the water, that's my independent variable. The dependent variable in that scenario is going to be the death of the plant. Or you could think of it in terms of how many plants survive without water, okay? So in terms of that, when you undergo or when you start the experiment, there are two variables you have to pay attention to, the independent and the dependent, okay? In terms of the scientific method, what I want you to be able to tell me are the steps involved in the scientific method. So I kind of stopped numbering here because I got ahead of myself. Right? We've got observation, which leads you to form a question, which allows you to come up with a hypothesis. Your hypothesis is tested via experimentation. Once you do an experiment, you gather results. Your results lead you to a particular conclusion, okay? Those are the basic steps of the scientific method. It's outlined in Chapter 1 of your textbook, okay? In terms of that, if you have any questions, please let me know. Thank you for your attention.